My name is Vaibhav, and my friend Jarek. In Polish it's said Jaroslaw, but then in short he's called Jarek. Anyways, we'll be talking about machine learning to moderate ads in real-world scenarios and not like doing a POC and competitions. So this is going to be a real one. First, I'll tell you what around the agenda and what the problem statement is. What is the exact problem and how do we solve it? And also a bit about OLX because not many people would know what OLX is all about. The first thing is the actual problem. So it will go like the problem, the model creation part, and going live with the product. So what is OLX? OLX is a buying and selling platform. It's like a classifieds platform where you can sell your products, where you can sell your mobile phones, your cars, any product that you have. And there will be many people trying to buy it out. So we operate in around 50 countries. So it's not like one simple country where you want to solve a problem. We have to solve a problem for many countries at the same time. We have around 60 plus monthly listings, and around 18 plus million unique monthly sellers. It's only the sellers part. There's a lot more when it comes to the buyers part as well. So what I'm trying to sell here is we are not dealing with a very small data set. We are dealing with a very big data set. So what do we actually do, and what do the moderators do? OLX employs a lot of moderators because all the data that we have on the site is user generated. So it's not like curated content. So everything that comes on the platform needs to be moderated. So what kind of problems do we have? What kind of problems are the moderators actually trying to solve? So there are many people who are trying to cheat the system. There are many people who are trying to violate the terms of services of the platform, and there are other people who are not educated enough or who really do not know how they need to publish their ad. So the avoidance of payment, a common example is you want to sell your BMW and then you have a car, you want to sell it out, but in certain countries you need to pay to post an ad on the platform. So once you have sold the car, people change their ad. Now they have a second small car, say a small Ford, and then they change the whole ad from BMW to a Ford, and then this is how they avoid a payment. The second biggest problem is they flood our websites with duplicate ads. So because as soon as you post an ad, there are so many other people trying to post that your ad goes down the page views as the page numbers, and you lose your visibility. So people try to post their ads multiple times, and this reduces the quality of content that we have on our platform, and it's not good for the buyers as well. They also try to create multiple accounts, because sometimes in certain countries you get free ads per customer, per user account. So you create multiple accounts so that you can post multiple things. Similar, now coming to terms of services, we have every site has its own terms of services. You cannot post a description, phone numbers on the images. So we have to get rid of all these kind of images. And so one common thing is like people try to sell guns and other things on the platform itself by they learn how to evade keyword rule-based system. So like in India, they were trying to sell money during the demonetization phase, where people were trying to sell banknotes on the platform, and this was totally forbidden. Miscategorization is basically people do not know which category their product should belong to. So we help our customers to categorize them better. I think, yeah, this would be enough. There are other problems that we are trying to solve, but then this limited time comes limited features. So I'll pass the mic to our...
Actually, I have one.
OK, so Jarek will continue with the offline model creation.
OK, so I'm Jaroslaw Szymczak, in short Jarek, and I'll tell you a few words about offline model creation. So this part when you start your project with. The very beginning is always the question how to convert your ad into a set of features. So what would you like to extract from the ad? What additional information, for example, about the user that posted the ad, you could concatenate with the information that you have about the ad itself, and so on and so on. So basically, the most important part for us is the title and description. And in any moderation, the content of the thing that is moderated is the most important. So any other things would be additional. And I will not go into exact details because some of those things are just specific to the way how our whole moderation tool works. So basically, when you have this number of features, and very often, you know, the classic of classics, TF, IDF, even more basic version is just a count of words, which is a count vectorizer. If you do it on a couple of million of ads, you can imagine how large the number of features that you have to process would be. So basically, you can do, for example, feature selection for some of the classifiers that might require it. Some of them do not, and we actually don't really need that much to do the feature selection, only in order to avoid leakage that I will tell more about later. So basically, once you have your features, things like category are straightforward. You just one-hot encode them with dict vectorizer in scikit-learn, for example, or with pandas get dummies. But then there, already in the previous talk, one of our colleagues mentioned, there is a hashing trick. So when you have this large number of features and they are very sparse, you don't need to have for each of the feature separate column. You can just reduce it by assigning each of such features to one of the bucket. An example with categories, I just would like to place them in 2 buckets here. I assign the buckets. It's not, of course, a random assignment, but this assignment is from the hashing function. And the hashing function simply gives you a large number. Then you define the number of buckets that you want to have. And either through modulo or some other operations, I'm not sure how exactly it is implemented in scikit-learn, inside, you simply have distributed your words between the number of buckets that you've chosen. So we use around 200,000 buckets for description and 50,000 buckets for title. And that works with a very similar quality to the count vectorizer itself. So it is actually, in our case, to speed up the computations. The thing that you need to be aware of when you develop the model, even in offline part, is the data leakage. So sometimes there is this epiphany that you have, wow, my model is so great, it's like I improved. I didn't even assume that it would be so good. And it probably isn't. Probably you just have a data leakage because probably you have the feature that wouldn't be available at the prediction time. For example, when we use the feature that we really had to be careful with is the number of ads that user have and the number of accepted ads that user have. Because if you combine the two and you save it after the moderation or the human labeling took place, you have your leakage, because actually this number reflects already the decision. So your leakage can come from many sources, because, for example, this count can be a query to a database that is then sent to you, to your service, by our team. So the leakage doesn't need to come from yourself, for example. You need to be aware of it, and the leakage that doesn't come from your processing is not possible to detect easily with holdout set. Because if you do the whole pre-processing yourself, just have a holdout set, do not touch the labels there, and you're good to go. You just evaluate that the performance is similar on holdout and on validation. But if your leakage comes from outside, you will have it already in your test set, in your holdout. And in such case, you need to monitor, if you have a live system, you need to monitor the live performance and ensure that it is the same as you expect. So just a few words about the algorithm. We wanted something that is state-of-the-art for structured problems, that when it underfits, you can do something like extend the learning time by the number of rounds, for example, and you overcome the underfitting. When it overfits, you can come up with various regularizations to ensure that it doesn't anymore. and it has efficient implementation. All things added gives XGBoost. So I will not go into details about XGBoost. I just have this shameless plug about the presentation that I made about it, and I encourage you to take a look. And I will focus more on evaluation of the model, because this is one of the most important parts. First, choose your measure. Accuracy isn't always the best, because if you have some rare event and you say that, for example, you have 1% of people that are sick and you want to detect it, and you say that everyone is healthy, you already have 99% accuracy. But it's totally useless. So also, one thing that was seen before is receiver operator area under curve of receiver operator curve. So basically, I think it is not the common knowledge about how to interpret the area under curve. So for binary classification, especially in medical sciences settings, area under ROC is like the gold standard to evaluate the tests. But what it actually means, this area under curve? It means that here you have the negative samples, here you have the positive samples. For each of the sample, you assign the score. And now randomly you take one negative and one positive, and the probability that the positive sample has a higher score than the negative sample is equal to area under curve. And this interpretation has a certain consequence. This consequence is that it doesn't really matter what is the proportion of your negative to positive examples, because this probability, as long as the distribution stays the same, also stays the same. So for example, in our case, when our models perform better and better, of course, we have fewer and fewer human-labeled examples of the ads that were positive. So the ratio, that were good ads, let's call it like that. So this ratio changes over time. And then suddenly you see that on other metrics, like for example, precision, your solution goes down, it deteriorates. The question is why? And the answer that we found out is because the area under curve, ROC, is the same, just the proportion of the data changed. So you need to think of one KPI that is relevant for your business. For example, this area under curve is nice, but doesn't really. Try to talk to business people about it, right? I dare you. You need to find out something that relates to business and to business requirements. So when you have this natural border of 0-5 score, like you have score from 0 to 1 and the 0-5, everything above that you classify as positive, the fraction of things that are positive there is called precision. So how precisely you predicted something. But you can modify this threshold. Sometimes you can simply don't give a decision. And when you increase this threshold, precision goes up. It has a certain limit, but it goes up if it's not totally random classifier. On the other hand, if you lower your threshold, you increase the recall. And recall is like you have this number of things that you want to catch, and it's the fraction of the ones that you actually caught. Like, for example, there are fishes in the sea, and how many of them, instead of other things like boots and so on, you caught. And as you see, there is this trade-off. You move this either up or down to have a curve that you can create. So this is an ROC, and this is precision recall curve. With this thresholding, and when you set the threshold after every possible value of thresholds that there are, you have a curve like that. And then, if your business requires from you that please find at least half of all bad ads that are there, at least, and try to be precise because we don't want to waste our moderators' work, you just freeze the recall and try to maximize the precision. You don't really care about the area under the curve, but simply about precision at this certain point. On the other hand, this is a requirement that we actually have. Human moderators have certain precision, and we don't want the machine to be worse because it's bad PR. So basically, you try to maximize recall, having the same precision as humans. So to conclude, just think of what your business requirements are and try to find a KPI that could be also a machine learning measure that could work both for business and for you, and that you could easily justify and actually optimize the thing that then business takes a look at. I give the floor back to Vaibhav. Thank you very much.
All right, so now you have done the POC part. So you have done a bit of modeling, you have done some kind of evaluation. Now you want to put this in production. So the first thing what you need to do is you need to see how big your data is. How is your data really, really big? So we deal a lot with, we started with dealing with a lot of count vectorizers, TF-IDF vectorizers, then came with hashing vectorizers. So we created a lot of feature space, but then the number of data points, at some point of time, we saw that the validation accuracy didn't increase. So if you keep the number of data points and if you can limit the feature space, then your data is not really big, I would say. But this is a very controversial topic. We can talk later about this one. So this is one thing that we do. So once we create a lot of features, once we have all the feature generation steps pipeline done, what we do is we export all these features using the normal scikit dump SVM-Lite format. This is very good because I do not know the speed. Speed versus HDA5 is a bit much better. Plus, you can stop at a certain point of time, and then you can continue later on if you really want to. So this is really memory efficient. You can separate your feature generation pipeline with the actual model training pipeline. So this is really good. The one drawback of SVM-Lite is you do not know the number of features. You do not exactly know the columns, the feature columns that you have. So you need to extract your feature columns differently. So what did we learn? We learned that do not use distributed learning if you don't need to. If you can have your job done in 1 machine or 2 machines at the max, it's good enough. Do not really over-optimize your problem. Choose your tech dependent. This is the same thing. Choose your tech dependent on the data size. If you cannot solve the problem on your local machine, there's always clouds. It can be Amazon, Google, whatnot. You can choose whatever. And always ask yourself a question. What is the most difficult problem that you want to scale? I would say it's people, because getting a lot of talented people is the problem. And if you really choose off the chart different algorithms or different solutions, you'll not get enough developers or data scientists to team up with you. So next thing is the model generation pipeline. What I would say here is automate, because if you do not automate, you will not be, your solutions will not be deterministic. Automation is a really big problem for us because we tend to have similar kind of models for all the different countries. So we do not want to do the same thing again and again for different data sets. We have a similar kind of pipeline. We use Luigi to automate the pipeline, and we make things deterministic this way. So it's not about only using Luigi. You can use anything. You can use Airflow. There's Uzi, and there's many more job management libraries out there. You need to choose whichever you're comfortable with. We are comfortable with Luigi because it is very simple, and if you know Python, you can easily make dependent jobs. Airflow is also good. Airflow UIs is really good. But if you're really doing like day-to-day jobs, cron jobs, Airflow is really good. But then if you're doing like once in a week kind of jobs, Luigi is good enough. So this is a normal Luigi dashboard where you see your pending tasks, your jobs in progress, your failed tasks, and all that sort. It's a very simple UI. You can't do much. This is our data model generation pipeline. So in the initial run, we extract the features, we create the SVM files, we export the SVM files, then we train an XGBoost model, and then model validation. So this is very specific to Luigi, because how does Luigi know if a job is done? So if you create an output file, this is how Luigi knows that your job is finished. And if your job breaks in the middle and you still have an output file, Luigi, if you run Luigi again, it will think, okay, your job is already done, why should I do it again? So always try to create the output file in the end. Creating dynamic dependencies in Luigi is really easy. You can use yield, you can use requires, whichever one to choose. The last thing is the workers thing. I didn't know when I started using Luigi about the workers. But then if you have a number of many cores on your machine, you can scale up your Luigi task jobs using workers. Now comes development and production environments. So normally when I talk to many people, data scientists, they create their models, they ship their models, and then they say, okay, my job is done. Well, this is not the case for every team. We create the models, we train the models, we evaluate, publish them, and monitor them. So how do we do this? The easiest way is to containerize. And this is how you manage your dependencies. So you create Docker containers, you orchestrate them using Kubernetes or whichever solution you want to choose, and then you deploy them. This is our normal model serving architecture. It is a very typical architecture if you Google for how to serve your Python models. We have Flask on top of our models. And of course, our learning model is scikit XGBoost based. And we do all the monitoring using Grafana and New Relic. And we save everything that is coming to us in Mongo cluster. Well, people will say, why Flask? Because Flask normally is process blocking kind of operations. People tend to use other frameworks in Python like Tornado. But you can easily use Flask as well. You can use G-Event, you can use queues. We use both, and then it's basically very fast. It's asynchronous, it's very fast, and then you can scale up very easily. This is one slide. This is our image model serving architecture. We do a lot with images as well. As I told before, we create hashes. So this is a fast pipeline because as soon as the images are coming in, we need to moderate all of these images. And so for each ad, we get like 4 or 5 images. So it's really exponential problem to solve the image images. We do a lot of hash generation. This is for similar image search. This is for duplicate detection, plus you can also use for image search itself. Then there are country-specific image moderation. Like in India, they don't allow human pictures, human with faces in the pictures, so you have to disallow. You have to remove these pictures. In Poland, they do not allow stock images, so you have to remove them. So these kind of image moderation. And then there's general moderation, NSFW, which we have to remove. Then comes category and tag prediction. As I told before, we need to categorize all the ads. Of course, people choose their category, but then using images, we can suggest them, okay, this piece of cup should go into a used product, I don't know which category. So we store all the models on S3. As soon as we deploy, we download the models from S3, and then this is how we make the prediction module. That's it. So yeah, so you have deployed your model into production. Everything is going fine, but your job is still not done. You need to evaluate how your model is behaving in real life scenarios, because the test data set that you chose before might change as the problem is on live. So here so what do we do here? What we do is in OLX, we sample all the predictions that come to us, and we send it to moderators. And moderators do not know that this is being predicted or not, as in this came from machine learning, or is it a live ad. So this is how we know that our models are behaving good or not. We calculate the error rates based on sampling. Second thing is, if you have a graph like this, you will know that you can create alerts when your error rates are going higher. And also, once you have a lot of models, so it's like 1 or 2 models you can handle itself, but then once you have 300 plus models and you have 2 people working on this 300 plus model system, you need to create reports. We create daily reports to see how we are doing in daily. because problems will change every day. There will be emails, there will be a spam in one country, and there will be different kinds of problems coming up in different countries. So you really need to be aware and proactive once you have deployed these models. So the lessons that we have learned using models in production is always batch. This goes for images, this goes for normal prediction. Using batching, using Kinesis, using Kafka, you can easily batch all your prediction messages, and you can easily do predictions on that. And this will definitely reduce your CPU utilization on the machines. Always modularize your code so that it's easy to read, to always make it clean code so that you can have many people in your team contributing to it. Plus, always Dockerize and orchestrate, because this helps you. And finally, once you have so many models running online. Definitely use a monitoring service, because if you do not, you will never know if your model is behaving badly. And finally, simple and easy tech. Do not take too much of headache of using Spark, Hadoop, clusters. Use simple, easy tech, which you can manage. And that's about it. So if you have any more questions, you can come back to us. So if you have any questions, please do ask.
Yes, any questions?
So thanks for the talk. Out of curiosity, you mentioned data leakage. You mentioned that, for instance, if you're taking data, your ads that have already been moderated, then of course it's leaking. But you also mentioned external leakage. What did you mean by that?
So, for example, not always you are responsible for the data preparation. And the leakage doesn't have to happen from your processing. It can happen from processing, for example, before you even acquired the data. That's what I meant. But it can happen externally outside of your supervision. So the fact that you know that you didn't introduce the leakage doesn't mean that there is none. So we didn't have this, but for example, when we receive the learning ads, it's also as a service. So we have a moderation tool. And from the moderation tool, we receive a JSON that has all the features that we need for the ad. For example, including the counts of number of ads that user have, and number of ads that user had rejected, and number of ads that user had accepted. If someone, for example, would do the count on those numbers after do the counts after the moderation decision would be done. For example, user has one ad and this ad is rejected. Instead of having both zeros because it's a new user, you would have a leakage because the only ad this user have is rejected. And that's how, for example, this external leakage could come into your data. Thank you.
Hello, thanks for the interesting talk. You made a lot of tech decisions like Docker, Kubernetes, Luigi, and whatever. Is there some technology that you regret, or I mean?
Yes, definitely. So when we started off with this project, we thought, yeah, we should definitely, because the data is really big, we should choose big data technologies, right? So we started with Spark ML, we had Kafka, we had Zookeeper, and all that sorts. Sooner we realized, yes, we used Spark ML lib for pre-processing, and sooner we realized that we are hitting a bottleneck with using Python and Spark. So yes, scikit pre-processing is good enough, hashing vectorizer is good enough, just go with scikit. Then came Kafka. Kafka, the problem was
You guys want to fix it, or maybe move to that mic? Can we get the other mic?
We can share.
Maybe it's this one. It's this one?
maybe that speaker.
Oh, it's just the speaker? Okay. Can you?
Yeah,
Okay.
it's good enough.
Okay, let's do this.
Or maybe
I think.
yeah.
Oh,
This is
okay.
good.
Yeah.
Everything is working. So yeah, the Kafka, the problem with Kafka was partitioning balance. So what Kafka does is, if you have many partitions, it will try to balance the number of messages in each of these partitions. And we were hitting a problem where it was not able to partition very fast. As in, it was doing a lot of balancing of the partitions, and then I said, yeah, too much of work. Just go with normal RabbitMQ queues for the time being.
I'd like to ask more about the implementation part. I mean, do you provide your moderation team with all the ads attaching with the score, or do you remove those ads before going through the moderation team?
So we in OLX do not just have machine learning as the basis of moderation. We have rule-based engines. So we tag along with the rule-based engines. So there are certainly definite ads that are caught by rule-based engines, and they're thrown away from the whole process. Then there are ads that come to the moderation queues. This can come from us, from our decisions that this needs to be moderated. In these kind of cases, we do not give a score. We suggest them, so that we say, we know that behind the scenes we are confident that this ad should be rejected because it has something like guns in the thing. So we suggest the rejection reasons to the moderators. We also suggest, like, if the price is wrong with the particular product. We also suggest if the category is wrong. So we also do a lot of suggestions so that we can help moderators make the decisions faster.
Hi, thanks for the talk. I would like to know if what kind of interface or how the communication process is between the data engineering team and the data science team.
And so this is a very so in OLX, of course we deal with a lot of data, and we have huge data engineering teams, and we have our own moderation teams. For us, it's not that big of a problem because everything that we have made is ourselves. Everything that comes to us comes through us as a REST API, and we validate all the data that is coming to us. So we do not have a lot of noisy data, but more or less structured data that comes to us. There is a lot of tracking data that other people deal with, and there it's a different engineering team, a different business unit in OLX that does that. For us, it's not that big of a problem of data engineering.
Okay, I think let's finish here. Thank you. Thank you for the talk again. And